Over the first week of class, we've talked a lot about unit conversions and the metric system. So in this video, I'm going to go over how to do some basic problems with dimensional analysis and how to convert between units for the metric system. So from class, you should remember that we have a base unit for our entire metric system, and we're using the MKS standard. So remember, M stands for meter. We're talking about any kind of distance or length something's traveled. K stands for kilogram, which is any kind of mass unit, if we have something that's, we're talking about how massive something is. And S stands for seconds. So anytime we're talking about a time and how long something takes, we're talking about that in terms of seconds. So when we want to convert between units, unit conversion was something we spent quite a bit of time on. We start with our base units for each of them, which for length is the meter, for volume is the liter, and for mass is the gram. As we convert between those units, we move based on powers of 10 away from this base unit. So going up the scale, we have deca as our first prefix. Our second prefix is hecta, and then third is kilo. For these prefixes, they all go in powers of 10. So we have our base unit, we have 1 power of 10 higher, 2 powers of 10 higher, and 3 powers of 10 higher. Going the other way, going down from our base unit, we have deci, which is 1 power of 10 lower, centi, which is 100th, and then milli, which is 1,000th. So as we move in the metric system, we change by a power of 10 depending on which way we're going on the continuum. So for an example, if I were to have 230 decameters, and I wanted to convert that to a different unit, perhaps I want to know how many kilometers that is, I simply find deca, I count over, I move 2 spaces to the right along the continuum, and then the decimal point in this number will move 2 spaces in the opposite direction to the left. So that I would have 2.3 kilometers as my final answer. You can move the other way as well, and you do the same thing. So if I had a different example, where perhaps I had 500 centiliters, so centiliters, and I wanted to find out how many liters that was. Once again, I'm moving 2 steps to the right, so my decimal needs to move 2 steps to the left, and I have 5 liters. One last example to really hammer this home. If I'm running a 10K and I start with 10 kilometers and I want to know how many meters that would be, I'll work my way the other way and we'll travel 1, 2, 3 places to the left, which now means the decimal needs to move 3 places to the right. So I start with my 10 and I go 1, 2, 3, and I fill in my zeros, and we end up with 10,000 meters as my final answer when I convert. The nice part about the metric system is that you can do this kind of conversion for any measure of meters, liters, or grams and have it work the same way. It doesn't matter what you're measuring, just what prefix you're using. The other thing we've spent some considerable time on this week is dimensional analysis. Dimensional analysis is a way to do math and convert between units. So based on what we've done the last couple days, at this point you've all at least began a lab where you found the weight in pounds of 10 pennies, you found your age in seconds, and some of you have found 3 meters per second, how many miles per hour that would be. So I'm going to give you several examples of ways we can do this. One of the first things that we need is a conversion factor, so something that takes us between a metric unit and an American unit. Something like 2.2 pounds is 1 kilogram. That's an example of a conversion that we would use to get from pounds to kilograms or kilograms back to pounds. So if I were to use that in my math, maybe I want to know how many kilograms I weigh. So I know that I weigh 190 pounds. When I'm trying to convert that to kilograms, I use dimensional analysis. Whatever unit is right here also needs to go on the bottom. So I try to fill in my units first so that I keep myself straight with my conversions. Whatever unit I'm trying to go to, in this case kilograms, needs to go on top of the fraction. So now when I look at this, I can come over to my conversions and say, oh, 1 kilogram is 2.2 pounds. So now I've got my ratio filled in. It's always a 1-to-1 ratio. They're equivalent to each other, and I can do my math. So when I do my math out, I'm going to take 190 pounds, multiply by 1, and then divide by 2.2. I always will divide by whatever is on the bottom of the fraction. So when I do this, I end up with approximately 86 kilograms. You can see that the pounds cancels out, and I'm left with just kilograms as my unit. The most important part of dimensional analysis is that you always have the correct units in the right places. If you reverse them, you're going to end up multiplying instead of dividing, and you're going to get an answer twice as large. So this is an example of a one-step dimensional analysis problem. It has 1 multiplication, 1 division, but only 1 ratio. If I wanted to take this a step further, and I want to know perhaps how many grams I weigh, I can start exactly the same way with 190 pounds, and I would set it up the same way, 1 kilogram over 2.2 pounds, because I still need to make that first step to getting out of pounds and into kilograms. The difference is that now I'm going to have a second step, and I want to go from kilograms to grams. So that when I cancel my units, pounds are gone, kilograms are gone, and all I'm left with is the gram. So what numbers need to go here? What's my ratio? Well, start with 1 for either of them. I know that a kilogram is larger, so I'm going to put a 1 here. How many grams is 1 kilogram? If you flash back to the unit conversion section, you can follow the continuum and move the decimal and find that 1 kilogram is 1,000 grams. So now I can do a little bit of math and I can find how many grams I weigh. So if I grab my calculator and I do 190 pounds times 1 divided by 2.2 times 1,000, I get that I have a mass of 86,363 grams. And so I found that by using the 2-step dimensional analysis problem to give myself an answer in grams. But it's all based on units. So pounds cancel, kilograms cancel, and I'm left with grams. The last one that I'll show you is one we did on our lab. How many seconds old are you? So I know that I'm 31 years old. So I'm going to start with 31 years. My next step would be to take that and decide how many days old I am. How many days have I been alive for? Years is my unit, so it needs to go on the bottom. And then on top of that, I'm going to convert to days. I know my ratio for days to years would be 365 days in 1 year. But I also know that I'm in days, and I'm not done yet. So years has canceled out. Days is now has to cancel as well. So days needs to go on the bottom of the fraction. So I have days on the bottom, and I'll go to the hour on top. So we'll find out how many hours I've been alive. I know that in 1 day, there are 24 hours. So now days has canceled out, and my next step would be to go from hours to minutes. And I know there are 60 minutes in an hour. These are all my conversion factors. After I get to minutes, the last step would be, of course, to go to seconds. And there are 60 seconds in a minute. So let's look. Years cancels, days canceled, hours cancels, and minutes cancels. And I'm left with only seconds, which is what I'd like my answer to be in. Doing the math, I start with 31, and I multiply by 365. I multiply by 24, multiply by 60, and 60 again, and I get 977,616. So I'm 977,616,000 seconds old at 31 years. So this was a much longer, multi-step problem where I had used several conversions to get to my final answer. You're welcome to use any conversions that you know. If you could have gone from hours and you knew that there were 3,600 seconds in 1 hour, that would be fine. You could have cut out the whole minute step. You'll notice I didn't use weeks or months here because I wanted to cut those steps out and I knew how many days were in a year. Those are all fine ways to do it. They may give you a slightly different answer because some of them are more or less correct, but it's a fine way to still do the problem. The last type, which we had for a couple classes, was when we tried to convert meters per second to miles per hour. And this one was a little more difficult because there's two parts of the fraction. So we were trying to walk at 3 meters per second. 3 meters per second. You'll notice that the units there's not just one unit, there's a top and bottom of the fraction. So as we do this, we're going to take one side of the fraction at a time. And keep in mind, it's always going to be on the opposite side of the fraction to cancel out. So 3 meters per second to miles per hour. We can go from meters to miles first. So meters is on the top, meters has to be on the bottom. So one of the ways we can convert this is to say that we can go to kilometers, and we can say there's 1,000 meters in a kilometer. So meters is canceled, and I've replaced it with kilometers. You could also go from meters to centimeters if you want to go to the inch, and then the foot, and then the mile. I'm going to go kilometers first, and straight to the mile. So kilometers needs to go away, which means it needs to go on the bottom of the fraction to cancel out. So I know that in 1 mile, there's 1.6 kilometers. So that is one of my ratios that I know. So now my top of my fraction that I want to end up with is fine. I'm in miles. But right now I'm in miles per second. So the seconds have to go as well. And so the last part of this equation is I need from seconds to hours. But different from our last equations, you'll notice that seconds is on the bottom of the fraction. So it's got to go on the top to cancel out. And we talked in the last one that we can go right from seconds to hours. And I know there's 3,600 seconds in 1 hour. So hours, even though it's on the bottom, is going to be what I'm left with because they have to be on opposite sides to cancel. And my final unit that I want to end up with is miles per hour. So now that I've set this up, I have my ratios all correct. I'm going to go ahead and put this in the calculator and see what we get. 3 divided by 1,000 divided by 1.6 multiplied by 3,600. And 3 meters per second becomes 6.75 miles per hour. There are several ways you could have done this problem. You could have separated them and done 3 meters to miles and 1 second to hours, and then put them back together and divide them, and it would work the same way. All in one step, this would be the way you get that done. I hope this has been helpful. If you have any questions, please come in and ask.